Hello and welcome. In this video, we are going to analyze WannaCry Ransomware, as you can see here. And to do this, we have to divide our process, and we divide it to two processes. And the first one is the static analysis. The second one is the dynamic analysis, and we need both of them along together. So we can start by static analysis, and the first thing we need to do is to open up our Symder. Please note or set in mind that I'm using a virtual machine and this is mandatory. I'm using Flare VM machine. Also, it's going to be installed inside Windows 10 operating system. Okay, the first thing I want to enumerate or to get is to get some information about our malware. That's why we're going to target strings, and in order to do this, you can use strings tool. But for me, I use another better tool called Floss, as you can see here. And we will know why I'm using Floss, and we also going to look for its results. So the first thing we need to specify is the minimum length. So we specify the minimum length with 8, and then we drag and drop our malware. We then redirect the results to our desktop, as you can see here. You should set in mind that I'm using Floss to get obfuscated strings and also encoded strings, and also is going to give us the straight sequence of strings. And also set in mind that I have already analyzed this WannaCry, so you're going to see that all the comments I'm going to use are going to be pre-written. Okay, now after finishing Floss process, as you can see, it's just printing out any encoded strings, also obfuscated strings, and bunch of sequence strings, as you can see here. So the first thing we need to do is to examine this results file. So I can use Notepad Plus, because I need to search for specified strings, and that makes sense to us. Maybe, yes. Okay, we are good. We can click or press Control plus F, and it's going to open up this window. And the first thing I need to search for any specified passes. So I'm going to specify C pass. And yes, we see first one here, and it's going to use, this is going to be actually a C format. Maybe it's going to pass this one to print a function or a specified function and so on. So we click at next, we see also another one and also another one with an arbitrary folder name, and also another one. And I think that's all. And the second thing we need to search for, such as registry keys, this malware might try to query or change it. So I'm going to specify reg, and yes, it's going to handle things about registry keys, as you can see here. Also another API functions and so on. And indeed, also we can search for DLL libraries this malware might try to use. That's why we see a bunch of them, as you can see here. And as you observe, it actually holds a lot of API functions that this WannaCry might hold and use. And the next thing I want to search for any exe extensions. So I want just to print out any programs might be going to located inside this WannaCry. So yes, we're going to see this is disk part. Maybe it's going to target disk partition to retrieve some information, and also another arbitrary PE folder, another one. And yes, this one might try to modify things related to Windows services, and another one, task scheduling, to schedule this WannaCry. So this might be a mechanism to make a persistent inside program. to make it self-persistent, and also cmd to execute some commands. So let's search for cmd to get more about this one. We only get this one, and I think we get nothing else. Maybe can be more specified. And yes, as you can see, also this malware might try to use some spicy Windows API to apply some encryptions, such as script gen key to generate keys and so on. And indeed, you can target any of these Windows APIs when you do your dynamic analysis process. And yes, also we see that it uses iCackles to retrieve the privileges and to try to elevate them and so on. And also to use attribute with +h. So it's going to give attribute to a certain folder or file to make it completely hidden. And we can also search for maybe this is a WannaCry. We can search directly for WannaCry word. And no, maybe WannaCry with only N. Yes, as you can see here. Yes. So the WannaCry going to print out or reveal this word to the victim or the user. And last thing I need to search for the HTTP protocol. And here beside our HTTP protocol, we see a certain domain. So this is a command and control domain or directly C2 domain. Maybe you can search for any other protocols such as TCP. Yes, get TCP info. So this might retrieve or going to retrieve the IP address of this machine to make some pivoting or botnet techniques. We can also search for FTP and maybe we find nothing. SMP, we also find nothing. And I think that's all about our process searching inside these strings. And at the end of this results, I just want to tell you, if you are not good at searching for certain strings, you can use another tool to sort strings for you by important strings and so on. And here we can use string sifter or flare strings to sort strings for us. So let's clear this one and now bring out flare strings, as you can see, and we specify the result file because it's going to sort it for us, and then we can specify another result file to examine it. And here we are. This is the file. So we can open this one with a simple notepad. It's going to sort the first important Windows APIs, as you can see here. And if we scroll down, we are going to see less important things according to string sifter or flare strings, as you can see here. And we also see some weekdays, and also some months names. Maybe it's try to target this victim machine, or it's going to run into a certain date and so on. So if we scroll down, we see also a bunch of Windows APIs and so on. You can examine this one yourself or do the normal scan as we did previously. And now I'm done with this one here. So let's close it. And second thing I want to use is Yara, because Yara is really powerful beside its rules. So we can bring Yara with -s, and this option tells Yara to print out any matches, also with their addresses, and -w to ignore any warnings, and we then specify our Yara rules file. And my rules file going to be at this location, and now we can drag and drop our malware. We then output the matches to this txt file, and it's going to be here, and see the matches, and as you can see here, bunch of matches, and actually going maybe this malware going to be under this name, also WannaCry Ransomware, as you can see here. Also some task scheduling at this, also as this is a certain domain, and they actually sorted this one to be malicious domain, also some privilege escalation techniques and so on. The good important thing about using Yara is that's going also to print out the address to any malicious port, as you can see here. Also is going to do some comments. Yara also detected this one, and also detected it's WannaCry according to this string. So this is actually a good thing you can examine. And as you can see also, it contains SMP protocol, and this malware got some help from SMP version 1 vulnerability to spread itself faster. So I think that's all you can do with Yara. Indeed, you can use some automation or automated tools such as PA Studio, but it's not this mandatory right now. And last thing or last tool I want to use is Detect Easy. Why? Because I need to know what programming language the developer used to write this malware. So we can drag and drop it, and it's going to sort to us that this is a C++ language. And scroll down, we see also the compiler, and also a good indication. Heuristic engine says that this might be baked. So we can go to the entropy, we maximize this one, and we see the sections, and the most important section for us is the resource section, because it's totally packed. As you can see here, the radiation is pretty high, so it is completely packed. And that's all about doing static analysis. And in the dynamic analysis perspective, the first thing we might need to target is the domain we could reach it out, as you can see here, because we need to know the malware what going to do with this domain. It's going to connect to it, it's going to retrieve some data, or it's going to do some functionality according to the response from this one. So we can keep this here and start our dynamic analysis process. And the first thing I would like to do is to give back the connection or internet connection to this machine. As you can see here, it's disconnected. That's why we need internet connectivity to examine or see how this malware going to interact with this one. So let's run our fakenet, and fakenet going to do some network simulation. As you can see here, it started. Ensure you can use another tool such as inetsim. It's going to give you the same functionality. Okay, we press yes, and here actually it started. So we can open our Edge browser, started to count things, and here, as you can see, our machine started to act as there is internet connection. So we can search for our Microsoft Edge browser, and maybe we can navigate to google.com, and yes, Google says that this is fakenet. That's why we have fake internet connection. As you can see here, this page actually generated from this default files. So if we can drag and drop this folder, it's going to be the same. So this is the default and the fake page that the fake net going to give it to any malware tries to connect to any domain. For example, we can call this one anything.com. It's going to print out to us the same response, as you can see here. And also, if it tries to target this domain to download another malware, that's why maybe it's going to be a dropper malware. Maybe it's going to download such as this program, and we're going to see how our fake net going to interact with this request. And as you can see here, actually it downloaded a fake PE file, and it's going to be the same as this one. So let's drag and drop it here, and we can examine this one. We run, and it's going to tell us this is a program comes from fake net simulation. And this one actually going to be the same as this one, because this is the benefits of using fake net, because indeed we need fake internet connection. So here we are good to go to detonate our malware, and let's detonate this one right now. And to make it more powerful, we can give it a higher privileges such as administrator, so we can run as administrator right now. And please observe here that our WannaCry actually made a request to this domain, so it's going to send a request to this domain, and according to this one, it's going to do some certain actions. So we can hold some seconds and see what will happen. And actually nothing will happen even if we have internet connection and so on, because this is a good indication that this malware not going to run if there is a response comes from the request we saw above. And we can examine this one by clicking to get rid of our fake net, and it's going to give us some results about any HTTP requests happened and so on. And the good thing about fake net, it's going to drop a pcap file, so we can examine this one to see what actually happened to our domain and to this request. So we can copy this one, or no need to do so. Let me maximize Wireshark and examine HTTP packets. So let's use filter to filter out all the HTTP requests, and we want to see only the requested one, and also maximize no, it's not related to us. And yes, here it is. This is the request. It's going to send to this domain twice, and actually our fake net gave it a response, as you can see here. That's why this malware didn't work. So it's going to depend on this domain to see if it's going to work or not. Now, after closing our internet simulation, now we have no internet or any fake internet connection. We can detonate this malware again to see how it's going to interact with our machine. So we right click and run as administrator, and we see what we will get. And it started to encrypt our files. Yes, and also dropped out this exe file. So let's double click it and see what will happen or what we can get. Yes, here we are. Actually, it encrypted our files and pop up this message to us that we have to pay to return back our folders. Please remind that before doing such a thing like this one, you should take a snapshot inside your virtual machine, as I did here. As you can see, you can take a snapshot. Maybe you can call this one WannaCry before detonating this malware to make it runnable. And you click OK, it's going to be taken. So here I have pre-snapshot, so I can go back to my safe zone and keep analyzing this malware by also performing another dynamic analysis techniques. Okay, my friends, after going back to our safe zone, now everything is fine now. we can keep analyzing this one. So the first thing I want to run in order to make a micro observing this malware is using procmal. So we can search for it, and yes, it's going to be here. And this is just process monitor and advanced one to monitor any program you need. And also second thing I want to use is TCP view, yes, to show us any TCP connection the malware tries to establish. And we also click agree. Now we don't need actually fakenet. Okay, let's close this one and let's clear this one. It's going to give us another results. So we can filter out the results by specifying the process name. So we go to the filter option, we specify process name, then is or contains. Let's go with contains. Then we specify our process name, then click add. Click OK, and it's going to be completely empty. So now we have our TCP view. I think we can minimize this one now and focus on our TCP view. And we can right click at this malware and detonate it again to see what we will get. Now we started to work and we see a bunch of connections just generated, and we also see some pattern here. So indeed this malware might try to perform some botnet techniques to spread itself inside our network, but the good thing is that we have isolated network, and now actually it stopped. So it maybe discovered things and did not complete its task. And if we go back or go to the process monitor, we see a lot of results. So let me minimize this one and focus on our process monitor. And we can see a lot of operations that this malware tries to do, such as create file, make some registry queries, creating, and so on. So we can focus on creating files to see the files that this malware might try to drop. So we go back to our filter options again, and we specify the operation, yes, here, and then we tell it contains, then create file. As you can see here, we add and then click OK, and we're going to see it actually created a bunch of files. Some of them may be going to be DLL, some of them going to be normal, and we scroll down, we see something or things not interesting for us. But yes, we found something interesting for us, and it's going to use task scheduling to target this one here. Let me get rid of this message and focus on this one here. So if we stay here and click at program tree or process tree, it's going to tell us that this is task scheduling comes from the WannaCry itself. Okay, no worries. Maybe it tries to target some passes. As you can see, we can filter out depending on this passes, but it's not this mandatory as we saw inside our results. So we can filter out also these things depending on this program. So we can filter out and we can see if this is mandatory or not. So let me get rid of this process name and also operation. We call it the operation, and this time we're going to specify the PID. Then tell it the PID is 7712. We click add, then okay. And yes, we see a bunch of things going to be happened according to this one here. And I guess it's not related to task scheduling, it's also related to our ransomware. So that's all. You can also target any paths that this malware tries to create or tries to retrieve, but as you can see here, nothing showed to us. So that's all for using process monitor and TCP view to monitor out this WannaCry. Now, or the next stage is to do some static analysis, or it's going to be advanced. That's why we need to do some reverse engineering against this one. And again, I'm going to target the domain we could retrieve to see what will happen according to the response it actually going to get after sending a request to this specified domain. So let me go back to my safe zone again and keep analyzing this malware. So here I would like to use Ghidra. You can use any disassembler or any tool have a decompiler such as IDA, Binary Ninja, or Cutter. For me, I'm going to use Ghidra because it's totally free and it gives us a solid functionalities. Now, after relaunching Ghidra, we can create a new project, non-shared project, and then we give it a name. I'm going to call this one example 1. And here we are. Then we drag and drop our malware. We go with the default options. If this malware going to be written using any other programming languages, you can choose it from here, but I'm going with the default one because it's the right one. Now we click OK at the import results summary, and we can double click at this program and it's going to open a code browser. So here, if we go, we're going to see that our code browser appeared and also giving us this simple message. Would we like to analyze this WannaCry? We click yes and give us some options. You can go with the standard defaults one, but if you would like to use any other options from this one, which not going to be unselected, such as this one, click at it and you can read the description. If you want to apply what the description says, just click at it and then go to analyze. But for me, I'm going with the default one, so I just click analyze directly and it's going to analyze the malware for us, as you can see here below. If you didn't get the message we saw previously, we can go to the analysis window or this option, then auto analyze, and then it's going to pop up to us this symbol window. We can also click analyze and it's going to be the same. After finish analyzing this malware, as you can see here below, in the decompiler, we see that there is an entry function. So Ghidra has successfully got the entry main function. We can see it in the imports. Now we go to the exports. We see that there is our function here. And if we can examine the imports, we're going to see some important Windows APIs we can target, but it's not really mandatory to put all efforts inside this WannaCry, because we saw previously that this domain we could target is going to be very important for us to diffuse the whole operation of the malware. So no need to go further and do a lot of efforts. But for you, if you want to know how this malware going to encrypt and decrypt files, you can also target this Windows APIs and also such important functionalities. And you can also set your cursor to the entry and click at this option, function called trees, which also going to be in this window, function called trees. And in the outgoing, we're going to see the functions which is going to be located inside the entry function. But again, we can directly search for the domain string we saw. So we go to the search window and then for strings. So search for strings and then we specify the minimum length, the alignment, and all is good to go. We can click at search and it's going to sort out all the strings it could retrieve. So we can directly search for our domain by clicking or typing HTTP. And yes, it's going to be here. Just once we click it, it's going to bring us to this one. Now we are going to see that this domain or this C2 going to be used inside these three functions. So I think these three references going to be the same, because if we click at any of those, it's going to lead us to the same function. And yes, it's actually the same function. So let's double click at any of them. And we scroll down, we're going to see that this domain going to be stored inside this variable. And if we scroll down, we see some interesting Windows APIs, because this Internet Open A going to work as a handle to create or initiate internet session. So if we scroll up, we're going to see some pattern here. Maybe it's going to act as encryption, because after all of this one, this variable going to be used inside this function here. So after making a handle and initiating a session to make a connection, this one going to be stored inside UVAR-I. And we can highlight this one. Second, set highlight. Yes, it's going to be used here. So after making a handle, it's going to use this variable inside another Windows API going to be Internet Open URL A. So this function actually going to try to connect to this domain, and this function is responsible for creating the request we saw inside our Wireshark. So after creating the request, it's going to save it inside IVAR2. Maybe we can highlight this one. Yes, here. And after highlighting this one, we're going to see that there is a simple if condition. And on the other side, in assembly, it's going to use test or CMB to do also if condition. So it's going to ask a question. If IVAR2 not equal to 0, which means that there is a response as we saw previously. So this function as a brief going to connect to this domain. If there is a response, which means that it's going to be equal to 1. If there no any response, it's going to be equal to 0. So here it's going to ask if there is no response from connecting to this C2 domain, please close the internet close handle function. It's going to close the handle that this function just created and opened, and then also return or give back 0, and then please execute this function. So this function going to encrypt our files, going to give us the message to pay to retrieve our data. So the interesting thing inside this one here is that this function, and if we click it, we're going to see it's going to initiate things such as creating services. And I want to remind you of something. Once we are going to do some dynamic analysis, we just passed searching for where the exe file came from, or there are any services just created. So I'm going to let this task for you to examine and observe. Now, if we go back, we're going to see that it's going to initiate things such as going to get a file, maybe going to make a service or search for a service, and so on. So let me go back, and no need to go further or go deeper. We just saw that if there is no response from connecting to this domain, this if condition going to be false, which is not going to execute this function. So if there is a response, as we saw previously, the session going to be closed and this program going to be exit. It's not going to encrypt our files, and that's all. So I think that's all from advanced static analysis perspective, and we can now get rid of Ghidra. And the last thing I need to examine or do is doing some dynamic analysis. That's why I'm going to use X32DBG, or it's going to be XDBG in general, because this program comes with 2 versions. But for you, use the proper version against the malware. Okay, here we are, and this is the window. We can go to the options, preferences, and disable all these options. We need just the entry breakpoint. We click save, and now we open our malware inside this one. So we go to the desktop, and then we upload our WannaCry, and it's going to be uploaded and stopped at our entry point location. Let's get rid of this one, and here we are. So the first thing we need to observe that we are at the program region, and if we go to the memory map, we're going to see that there are a lot of locations. If we click at this .text inside our WannaCry, double click it, it's going to lead us to this location. But it doesn't really matter where are we, because the first thing we need to do is to search for the specified domain. That's why we can right click at any empty space, and then we go to the search for, then current region, then string references, and it's going to print out everything to us. Or the second thing I want to search for is the HTTP domain, and if we double click it or right click and then follow in this assembler, it's going to bring us back to this assembler window at this location. And we also see this interesting two functions. So here I'm going to set a breakpoint. So right click, then go to breakpoint, then toggle. If we go to the breakpoints, we see one breakpoint here. So now we are good to go. We are good to detonate this malware again. So we click at run or debug, then run, and it's going to hit our breakpoint, and here we are. So we can executing these few instructions by clicking at step over, or we can just directly click F8. Yes. So we keep executing these few functions to see what we will get. And now we are going to target the first function. So we just execute it and wait, because it's going to be in the running state. And now after executing and after making or initiating internet session by using this function, we keep executing to see how this function going to do or going to interact. So now I'm going to call this function, and now it could successfully send a request to this one. So the second thing we need to observe that there is if condition, which is going to be here. If you can't translate these instructions, please run Ghidra beside x32dbg and try to understand what's actually going to happen with these instructions by getting some help from the decompiler inside Ghidra. And now we keep scrolling, and we're going to see that there is a symbol comparison, and it's going to make a jump. And as you can see here, jump is not taken, which means that it's going to execute this function, and this function going to encrypt our files inside our operating system. So if we scroll down by keep executing, and now jump is not taken, which is not going to ignore this function, which means that our file is going to be encrypted. And now please observe, maybe let's resize this one because I want to show you something. Once we hit this function, I want to observe what will happen to my our Flare VM. And now I just run this function, and after running this function, you are going to see that's going to encrypt our files and encrypting our data and so on. And now I don't need to do further analysis. I just want to tell you that we can diffuse the functionality of this WannaCry by patching this one. So we can right click at this one, then binary, then fill with noobs. And once filling this one with noobs means that we just patches this malware, and it's not going to infect our operating system. But I just want to tell you that's not a good solution, because yes, this malware, after patching, it's not going to infect our operating system, but it's going to infect other computers overworld. That's why no benefits of doing such. Indeed, if we want to diffuse the functionality or diffuse the malicious actions that this malware going to take, is by making the domain always giving us a response. And in order to do this, we can buy the domain, and once we post the domain, any computer or wallet going to connect to this domain going to take a response, which means that this function not going to work. So I hope you really enjoyed watching this video, and see you in the next one.